Rotational motion is a motion of an object in which it rotates or spins about a fixed axis. Every point on the object moves in a circular path around that axis. Example, a fan blade and clock hands. The similarity between rotational motion and a computer hardware fan is circle path of motion and use of bulb.
So rotational motion is a movement of an object spinning around a fixed axis. As you can see on the screen, this is how rotational motion works. While this topic is closely related to physics, there are also applications of this concept in biotechnology, and it is called the centrifuge. Centrifuge will be used to separate substance from a solution, and this works by spinning the substance at a high speed, which will make the heavier component like red blood cell to sink to the bottom of the test tube, while lighter component to remain on top. In conclusion, the use of centrifuge make it easier to collect data of a specimen, and without centrifuge, the process of separating substance will be much longer and less efficient.
Hello everyone, my name is Asyiqin Binti Abdullah and my metric number is BS2411044. So I will explain about the thermal physics in PCR machine. It is very important in biotechnology. PCR is a laboratory technique used to amplify DNA. This process depends on precise temperature control. In a PCR machine, thermal physics control how heat is transferred to the DNA sample during repeated heating and cooling cycle. So this is an example of PCR machine. They have a 7-inch color touch panel, high performance temperature control system, rapid heating and cooling, and support large capacity problem storage. There are 3 thermal cycling in PCR. The first one is denaturation at a high temperature. The second one is annealing at a medium temperature. And the last one is extension at a low temperature. As we can see in the picture, this is the use of the thermal cycle. This is the example of polymerase chain reaction. So, thermal physics is essential for ensuring accurate and efficient DNA amplification in biotechnology. Thank you.
This process is vital for research and diagnostics, allowing us to see invisible temperature differences. Imagine a dark room with a person. A thermal camera simulation instantly reveals their body heat. Warmer areas, like the head and torso, glow in vibrant reds, oranges, and yellows, indicating higher temperatures. Conversely, cooler backgrounds and extremities appear in deep blues and purples, creating a striking visual contrast. This visualization uses a simple color map, linking temperature ranges to distinct RGB color values. Lower temperatures are assigned to cool colors like blue, while higher temperatures map to warm colors such as red.
Rotational dynamics explains how objects rotate over time, and it plays a key role in computer graphics. In mathematics, rotational motion is described using angles and angular velocity, which measures how fast an object rotates. In computer graphics, rotation is calculated using matrices that transform object coordinates in 3D space. By increasing angular velocity over time, animations appear smooth and realistic, especially in games and simulations. Rotational dynamics allows realistic physics such as spinning objects, collisions, and momentum conservation. These principles are used in video games, simulations, animations, and virtual reality. Rotational dynamics connects mathematics and computer graphics to create realistic motion.
In biotechnology, spinning is not random. It is physics, rotational dynamics. Rotational dynamics explain why an object rotates, focusing on torque and moment of inertia. In biotech labs, this principle powers the centrifuge. When a centrifuge spins, torque from the motor causes angular acceleration. Heavier particles, like cells or organelles, have greater inertia and move outward faster under high rotational force. By adjusting rotor size, speed, and mass distribution, scientists precisely control separation of blood components, DNA, and proteins. So, in biotech, rotational dynamics isn't theory. It is how we isolate life.